Hi, now we'll see the SSS algorithm. So for SSS, start from the root. First, for calculating the reference nodes, repeat at a maximum node, choose all the children's. At a minimum, choose one child until the horizons are reached. So the follow this procedure for the first in the forward direction. For maximum, choose all. For minimum, choose one. Okay. So first we'll consider whatever the given thing we're having. So what we're here using is for maximum choose all, for minimum choose one. Maximum choose all, minimum choose one. Whenever we are choosing the one for the minimum, we will consider the leftmost, and for minimum choose one, for maximum choose all, for minimum choose one, choose one. So these A, C, I, K are the horizontal nodes. So this is the reference nodes are in the initial, that is the nodes in the initial clusters formed by the SSS. This is a procedure to follow for calculating the initial clusters formed by the SSS algorithm. For max, choose all. For minimum, choose one. Whenever we are choosing the minimum one, choose the leftmost until the leaf nodes reached. So whatever the nodes are having, these are the first horizon nodes in the initial clusters by the SSS. So now we are allocating A1, the names for the nodes B1, B2 like this. So this is the E1, E2, E3 and so on up to. So what are the nodes we are having? E1, E3, E9 and E11. So the values are 32, 29, 96 and 59. So these are the values now in the queue with the status as solved. Okay. Now arrange these things from like maximum to minimum. So E9, E11, E1 and E3. Now pop out this E9, that is the value as 96. E9. So this value is the first solved. E9 is in the status as solved. So to become this minimum node has to be solved. Both the nodes has to be solved for the pair. So the minimum node has to be become the status as solved means both of his all the children has to be solved. So here what we are having next, we will go and see this value j. Okay. So okay, now E10 value. E10 value will becomes E10 will becomes the solved. Okay. So E10 becomes solved. E10 value is 56. E10 value is 56. It is the solved. When both E10 and E9 solved, then D5 is solved with the value as 56. So D5 is solved with the value as 56 because it is the minimum node. Okay. So D5 is the minimum node. We will get it as 56. Okay. Now when D5 is solved, okay, if any one node is solved, then the maximum node is solved. So when D5 with 56 is solved, then automatically C3 will be solved. So C3 with 56 is solved. Okay. Now we are having the nodes C3 with the 56. So already E11 is having 59 with solved, arranging in order. C3 with the 56, E1 with 32 and E3 with 29. Next pop this E11, E11 with 59. So E11 with 59 means next the node is E12. Okay. So E12 is solved. E12 it is 69. Okay. E12 is solved. When E11 and E12 solved, then D6 is also solved with value 59 minimum value. So D6 is solved next. Next D6 with value 59. D6 is also solved. Okay. When D6 is solved and D5 is solved, C3 is wait, no need to consider this. Okay, C3 is solved. Okay. Now when C3 solved, C3, so C3, both the nodes, wait a minute. Okay, now E10 with the 56 is solved. So when both the nodes of the minimum node I and j both are solved, then D5 is solved with value as, so D5 is solved with value of 56. That is the minimum value. Now if you see in the cube, this is removed. So we are not having the cube. Now we are having in the cube 11, 59, D5 56, E1 32, E3 29. Okay, now these are all the in the solid state. So E11 is the, now we need to remove this E11. So the E11 59, next we are having E12. Okay, next E12 will be in the solid state. When E11 and E12 solved, then D6 will be solved with a value of 59. So D6 with solved with a value of 59. Okay. Now in the queue we're having, now in the queue we're having D6, D5, E1, E3. So 59, 56, 32 and 29. D6 and D5 both solved. So when D6 and D5 both solved, C3 is solved. So now C3, E2, E3. We are having only these three in the queue. Okay. Now when C3 is in the solved, next the node C4 becomes the active state. Now C4, then we'll see the children's, that is D7. D7 will go and see these 13 and 14, that is M and N nodes, and will receive it as 64. Okay, so D7 will be in the solved state, D7. Okay, so next D7 will be solved with a value of 64. So when D7 is solved, then automatically C4 is solved with a value of 64, because we are not considering the total two nodes, only one node is enough for C4. So D7 is solved with 64, then automatically C4 is also solved. C4 is also solved with a value of, C4 is also solved. Okay, next when C3 and C4 solved, then B2 becomes solved. B2 becomes solved with a value of 59. That is the minimum of these two. When B2 solved, then automatically A1 is also solved, because any one node is solved, then automatically the parent node is solved. So A1 with a value of 59. Okay. Now if you see what are the nodes in the solved condition, first we see that E1, E3. Now if you see the solved nodes, okay, so E1, E3, E11, E12, okay, so in the solid state E1, E3, E11, E12, E1, E2, E11, E12, E10, E10 is also there, okay, E, E10, E11, E12, next, so next we saw these three, 13 and 14. For D2 becoming the solved. So E13 and E14. These are in the solid state. So E1, E3 if I write in the alphabetical order. Okay. So A, C, I, J, K, L, M, N. These are the solved nodes and remaining are the pruned nodes. Okay. So if you see the one, okay, what are the nodes? What are the horizontal nodes that are assigned solved stated by SSS? So we should not consider this OP. Okay, so because whenever this node is solved, then automatically this will be solved. No need to check for this node because any one of the node of maximum node is enough to solve this one. So when this is solved, then automatically this will be solved. So this will be pruned. OP will be pruned. Okay, so up to Mn only we will have. Okay. AC, IC, KL, Mn. So the remaining nodes are pruned by the SSS algorithm. Okay, now we'll see one more example for the triplet algorithm. Okay, this is one of the practice assignment questions. So we will see with the starting onwards A1, B1, B2 and so on. Okay, now if you see the horizontal nodes for this one, maximum, okay, we need to select both for a minimum 1. Okay, so 11, 48, 25, 30. 11, 48, 11, 48, okay, 11, 48, 25, 30, 25, 30. Okay, so these are the divisions E1, E3, so E1, E3, E9, E11. E9, E11 are the clusters, first clusters, 11, 48, 11, 48, 25, 30, 25, 30. Now, if you form a queue and write in the order E3, 48, E11, 30, E9, 25, and E1, 11. So, first E3. Okay. So, when E3 removed, E3 solved. So, these are all in the solved state. These are all in the solved state. When E3 solved, then we will go for this one, that is E4. Okay, so next E4 solved. When E3 and E4 solved, okay, E3 and E4 solved, then D2 becomes solved. D2 solved with a value of 48. Minimum is 48. Okay, now in the queue we are having E3, in the queue we are having D2 with 48, E11 with 30, E9 with 25, and E1 with 11. All are in the solved state. Okay. When D2 is solved, then C1 becomes solved because any one. So now C1 becomes solved with 48. Now we are having in the queue E11 with 30, E9 with 25, and E1 with 11. And now when C1 becomes uh, solved, then we'll go for the another tail, that is C2. Okay. Now C2 will be in the live. Okay. So next D3 and D4 becomes live. When D3, okay, D3 live, and D3 will go for these two, D5 and D6. So both will be solved and will get D3 as 53. So D5 will be solved and D6 will be solved, and then D3 will become solved with a value of 53. So D3 solved with value of 56, because when both the nodes are solved for a minimum node, then D3 will be solved. When D3 becomes solved, then C2 becomes solved, because any one node of maximum node is enough. Then C2 becomes solved. C2 becomes solved. Okay. When C1 and C2 becomes solved, then B1 will be solved. Okay. So then B1 will be solved with a value of, so which is having the minimum C1 and C2. So C1 is 48. So when B1 is solved, then A1 is solved, because any one node is enough. So A1 is solved with a value of 48. So I am not writing entire thing, just I am saying only the nodes with the solved. So A1 is solved with 48. Okay. So this is the procedure. For now we will see what are the nodes in the solved nodes are means. Okay. Now the solved nodes are, first we will start from E1, E1, E3, E9, E11, E1, E3, E9, E11. Okay. E9, E11. Next E4, E4 is solved. Okay. Next E4. After E4 we will went for the E4 is, after E4 solved, then E5, E6. That is when D3 is solved. E5 and D3 is solved. E5 and E6. E5 and E6. Next E9, E11. So E9. So these are the nodes in the solved, remaining are in the pruned condition. Okay. So E1 means A, C, E4 A, B, C, D, E, F, C9 is I, K. So these are the nodes in the solved. Okay. So if you see that one, practice one, 11. Okay. Okay. So what are the, list the horizon nodes that are the initial clusters formed by the triplet algorithm. Okay. So if we see the initial clusters are E1, E3, E1, this one 1148, E1, E3, E9, E11. So A, C, I, K. at the initial clusters. So what are the nodes that are assigned by solved status are A, C, D, E, F, I, K. A, C, D, E, F, I, K. These are the solved nodes. The remaining nodes are in the pruned state. Okay. So this is about the triplet algorithm.